Hello, welcome to our 6th video in differentiation, and today we're going to be doing a problem involving L'Hopital's rule. So, alright, we've gotten a fairly ordinary looking function, and we've got to find a limit involving this function. So this is what we have to find. And we've got some graph here. So, alright, whenever you're doing a limit, right, you have to try direct substitution right away. So let's show the work here. So what we're doing is splitting this limit up into quotient, right? That is a limit property. And then you know that f is continuous, so you know that the limit is equal to pi over 2, right? You want to mention f is continuous at pi over 2. And likewise, g is differentiable, right? So that means that g is differentiable, which implies that g is also continuous, right? In order to be differentiable, you have to be continuous at pi over 2. And also everywhere, but pi over 2 is what matters. So let's try then. So f of pi over 2 is going to be e to the pi over 2 cosine pi over 2. And then g of pi over 2, let me just move this stuff real quick. So g of pi over 2 is going to be 0, right? And right away we have a 0 in the denominator, which is very unfortunate. That's a red flag. And not only do we have in the denominator, but if we evaluate what cosine of pi over 2 is, right, your unit circle, pi over 2 is right there, it's going to be 0. And right, 0 times this is just going to be 0. So we have an indeterminate form here. So now we know that indeed we're going to have to use L'Hopital's. So since limit x approaches pi over 2 f of x, and the limit as we approach g of x is 0, we're going to use L'Hopital's rule. L'Hopital's. Okay, so what is L'Hopital's rule though? Well, we know that this limit is just going to be x approaches pi over 2, but then you're going to differentiate the numerator and the denominator separately. Don't get this confused with the quotient rule, right? If you're differentiating, something like this, right, that's totally different, right? That's where you get this f prime g minus, f prime g minus blah 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 and all that stuff over g squared. So the point is, this is not the same as the quotient rule. You're just differentiating the numerator and the denominator separately. So like that. So okay, let's get to it. So right, so now we're going to split this up into a limit again. I mean, this might be extra work, but for the AP exam, usually more work is better than less. Okay, so now we've got to find the limit as x approaches pi over 2 f prime. So f prime is continuous, so you can just evaluate it like that. So f prime is continuous at pi over 2, right? That is the definition of continuity. The limit has to be the same as the function value. And g prime is also continuous at pi over 2. Now, I'd like to point out some tricks that they're doing here. They've put this this cusp in the graph of g prime because g prime is not differentiable right here at pi over 2. But it is continuous. It is continuous, right? Because the limit will still exist, but the derivative won't. So I think they've purposely done that to trick you. But you have to recognize that you only need G prime to be continuous in order to, just to say that, oh, it's going to be G prime of pi over 2, right? Okay, so now we just have to evaluate this. So f prime, well, we've got to find f prime first. So let's do that over to the side. So f of x is e dx cosine x, right? Yeah. And then we're going to use the product rule. So f prime g plus fg prime. And then our f is going to be e to the x, and then our g is going to be cosine x. So we're going to end up getting an e to the x, and then g is going to be cosine x. And then I'm just gonna leave that there as blank space, and then f is going to be g e to the x as well, right? The derivative of e to the x is also e to the x, and then g prime is going to be a minus sine x. That's why I left a space there. Okay, great, and we can factor an e to the x out if we'd like. Great. All right. So now let's just evaluate this at pi over 2. Alright, we get this ugly e to the pi over 2, but that's okay. Get some trig functions that we can evaluate. And so e to the pi over 2, and then cosine pi over 2 will be 0, right? That is what we used over here. And sine pi over 2 will be 1, so you just get minus e to the pi over 2. Okay. So, right, f prime of pi over 2 is minus e to the pi over 2, right? And then g prime of pi over 2, well, what is that? Well, we have the graph of g prime here. Pay special attention to the captions of the graphs here, because if you thought that this was like, I don't know, some other graph involving like some other function of g, like maybe this was g of x instead, then you'd be confused about how to get the derivative. Like if this was just g, right, the derivative doesn't actually exist if this was g, but no, it's a g prime of x. So you're just evaluating at that point, and at that point it's 2. So g prime of pi over 2 will be 2. And you will arrive at your final answer pretty quickly. So it's just minus e to the pi over 2 over 2. And we're done. Some important things to highlight here. They're asking us to justify our answer. And when we justify, one of the things in the scoring guidelines is that you have to show that g prime is continuous at pi over 2. You have to show that because, like, technically you can't say that the limit is the g prime of pi over 2 without continuity, right? And so that's why I showed it for all of these functions over here. That they don't explicitly grade this, but I'd say, get into the habit of that. Taking the limit is not the same as evaluating, unless you're continuous. So ideally you should show that just so that you won't lose points, because it is a common mistake to not mention that g prime is also continuous at pi over 2. You just sort of just do it, but no, you have to mention that because technically you can't evaluate that limit without that fact. So yeah, that'll be all for this video. Feel free to leave feedback or questions in the comments. Hope this was helpful, and I'll see you guys in the next one.